Hello everyone. In this video, we will see two more properties of gamma function. The first property is integral 0 to pi over 2 sine to the power mx times cos to the power nx dx equals to gamma m plus 1 over 2 times gamma n plus 1 over 2 over 2 times gamma m plus n plus 2 over 2. And the second property is integral 0 to infinity e to the power minus x square dx equals to 1 over 2 square root of pi. So these are the two more properties of gamma function, and we will prove these two properties. So for the proof of first property, we have integral I equals to 0 to pi over 2 sine to the power mx times cos to the power nx dx equals to 0 to pi over 2. This is same as sine square x to the whole power m over 2 times cos square x to the whole power n over 2 dx equals to the integral 0 to pi over 2. This is sine square x whole power m by 2 times, and the cos square x is 1 minus sine square. So 1 minus sine square x and whole power n by 2 dx. So now we have to use the substitution method. Let t equals to sine square x and differentiate both sides with respect to x, then we will get dt equals to 2 sine x cos x dx, or dx equals to dt over 2 sine x cos x equals to dt over 2 times sine x is same as the square root of sine square x. So the square root of sine square x times, and we know that cos square x equals to 1 minus sine square x. So cos x will be the square root of 1 minus sine square x. So here we can write 1 minus sine square x equals to dt over 2 times, so the sine square x is t, so you can write t, and 1 minus sine square will be 1 minus t equals to dt over 2 times. So this is same as t to the power 1 over 2, and this is same as 1 minus t to the power 1 by 2. So since we changed x in terms of t, we have to change the limit of x in terms of limits of t. Initially we had 0, so put x equals to 0, we will get t equals to 0, and put x equals to pi over 2, then we will get t equals to 1. So our integral becomes I equals integral 0 to 1 t to the power m by 2 times 1 minus t to the power n by 2 times, in place of dx now we can write dt over 2 times t to the power 1 by 2 times 1 minus t to the power 1 by 2 equals to, so we can bring this 1 over 2 in the front, so 1 by 2 times the integral 0 to 1, and we have t to the power m by 2 over t to the power 1 over 2 times 1 minus t to the power n over 2 over 1 minus t to the power 1 over 2 and dt equals to 1 over 2 integral 0 to 1. So since the base is same, we can subtract the powers. We will get t to the power m by 2 minus 1 by 2 times, here also the base is same, so we can subtract the powers. 1 minus t to the power n by 2 minus 1 by 2 dt equals to 1 over 2 integral 0 to 1 t. So minus 1 over 2 is same as minus 1 plus 1 over 2. So instead of this minus 1 by 2, we can write minus 1 plus 1 by 2. So we have m by 2 and we can write plus 1 by 2 minus 1 times, here also 1 minus t to the power n by 2. So instead of minus 1 over 2, we can write plus 1 by 2 minus 1 and dt equals to 1 over 2 0 to 1 t to the power. So here we can take 1 over 2 common from this term here, then we will get m plus 1 over 2 and minus 1 outside times 1 minus t to the power. So taking 1 over 2 common from these two terms, we will get n plus 1 over 2 minus 1 dt. So let's go here. So our integral I equals to 1 over 2 integral 0 to 1 t to the power. I will let this m plus 1 over 2 as capital M. So capital M minus 1 times 1 minus t, and I will let this n plus 1 over 2 as capital N, and we have minus 1 dt equals to 1 over 2. So previously we learned that integral 0 to 1 x to the power m minus 1 times 1 minus x to the power n minus 1 dx is beta m comma n. 1 over 2 times beta capital M comma n. And we also learned that beta m comma n equals to gamma m times gamma n over gamma m plus n. So we can write 1 by 2 times, instead of this we can write this gamma m times gamma n over gamma m plus n, 1 over 2. So gamma, so the capital M is m plus 1 by 2, so we can replace it with small m plus 1 by 2 times, and the capital N is small n plus 1 over 2, n plus 1 over 2 over gamma. So substituting the same thing here, we will get m plus 1 over 2 plus n plus 1 over 2 equals to 1 over 2 times gamma m plus 1 over 2 times gamma n plus 1 over 2 over gamma m plus n plus 2 by 2. So this proves that our integral 0 to pi over 2 sin m x cos nx dx equals to 1 over 2 times gamma m plus 1 over 2 times gamma n plus 1 over 2 over gamma m plus n plus 2 over 2. So this completes the proof for our first property. Now we move on to the second property. So our second property was integral 0 to infinity e to the power minus x square dx equals to 1 over 2 and square root of pi. So to prove this, it is quite simple. So all we have to do is put t equals to x square and differentiate both sides with respect to x. We will get dt equals to 2x dx, or dx equals to dt over 2x dt over 2. So we let t equals to x square, so x must be square root of t. Since we changed x in terms of t, now we have to change the limits as well. So put x equals to 0, we will get t equals to 0, and put x equals to infinity, we will get t equals to infinity. So the limits are same. So our integral I equals to 0 to infinity e to the power minus, in place of x square we can write t now, and in place of dx we can write dt over 2 times t to the power 1 over 2. So square root of t is same as t to the power 1 over 2. We can bring this 1 over 2 in the front, 1 over 2, and integral 0 to infinity e to the power minus t times t to the power minus 1 over 2 dt. I equals to 1 over 2 integral 0 to infinity e to the power minus t times t to the power. So minus 1 over 2 is same as 1 over 2 minus 1 equals to 1 over 2. Now in gamma function we learned that gamma n equals to integral 0 to infinity e to the power minus x and x to the power n minus 1 dx. So in this case, in place of x we have t, and in place of n we have 1 over 2. So this must be gamma 1 over 2 equals to 1 over 2, and we know that gamma 1 over 2 is square root of pi. Therefore our integral I, which is integral 0 to infinity e to the power minus x square dx, is equals to 1 over 2 times the square root of pi. So these were the two more properties of the gamma function. In next video we will evaluate some integrals using the gamma functions. Thank you.